Hello, my name is Mona Rajans, and today I'm going to talk about how to use FHIR, which is often pronounced as FHIR, by doing a very detailed video tutorial in this particular video. And hopefully, by the end of it, uh, you can be very familiar with what FHIR is and how to use it. So, let's get started. So the first question is, what is FHIR, and obviously, what is it used for? So FHIR, or the Fast Healthcare Interoperability Resources, uh, is a draft standard describing data formats and elements, which are also known as resources, and an application programming interface, that is an API for exchanging electronic health records. FHIR essentially builds on previous data format standards from HL7, like HL7 version 2.x and HL version 3.x. But it is much easier to implement because it uses a modern web-based suite of API technology, including an HTTP-based RESTful protocol, HTML and cascading style sheets, and user interface integration. It also uses a choice of JSON, XML, or RDF for data representation and Atom for results. One of the many goals is to facilitate the interoperation between legacy healthcare systems, making it much easier to provide healthcare information to healthcare providers and individuals on a wide variety of devices, from computers to tablets to cell phones, and also to allow third party application developers to provide medical applications which can be easily integrated into existing systems. FHIR also provides an alternative to document centric approaches by directly exposing discrete data elements as services. For example, basic elements of healthcare like patients, admissions, diagnostic reports, and medications can each be retrieved and manipulated via their own resource URLs. FHIR was supported at an American Medical Informatics Association meeting by many EHR vendors, from which vendors which value its open and extensible nature. FHIR essentially is the next generation HL7 standard. 3 years after the first release of FHIR, it has remarkable uptake and is being implemented for a broad range of use cases. Yet, beyond those involved in developing the standard, the early innovators using it, knowledge about FHIR is still limited. FHIR, in some ways, has truly changed the meaning of interoperability. For example, the amount of data about an individual's health and healthcare has grown exponentially over the recent decades and continue to do so. The data is no longer just in clinics and hospitals, but comes from an increasing number of sources. Interoperability used to mean connecting two or more systems. Now it means accessing data in multiple systems from one point, one client in real time. This is how many of the web applications we use today function: social media, e commerce, financial services, and much more. In a similar way, FHIR is the technology that will allow us to see all of an individual's health and healthcare data in one view. Let's talk a little about how interoperability is done differently with FHIR. So FHIR is based on the same technology as mobile and web applications in other industries and on the definition of data elements and concepts in healthcare. Past HL7 standards have been published in multi-month cycles and as documents. These documents required interpretation by implementers to create software applications. FHIR has instead followed the processes of open software development, relying on wikis and social media and an online draft of the standard that is publicly accessible. Development has also been driven by FHIR connectathons that are an integral part of the development process. So, because this all sounds so amazing and so useful, there has been a rapid adoption of FHIR. With the third release of the FHIR specification in early 2017, FHIR has already seen significant adoption. Implementers have created FHIR interfaces and applications along a broad range of use cases. They range from enabling clinicians to access data in their own systems with mobile apps to using FHIR to pass patient context from an EHR to decision support services, also to identify matching and records discovery. So some of the specific use cases of FHIR are as follows. The first is the personal health record, or the PHR. So in a typical PHR scenario, an electronic medical health record system, or an EMR through many other names and acronyms are also used, provides a RESTful API that allows patients to access their own medical record via a common web portal or mobile application, usually provided by a third party. In this scenario, the PHR provider provides the patients with a login that identifies them, authenticates the client using an appropriate OAuth server for the login, and restricts the client to viewing records associated with the specific patient. The EMR exposes a FHIR server that supports the search and read operations on the following resources: the patient resource itself, the search and read on the document resource, and search and read on a set of clinical resources. The second section is about document sharing, or also called XDS. One common way to integrate healthcare information from a variety of sources is to build a repository of documents around a patient record. Building a repository of documents allows for less stringent alignment around policy, procedures, and record keeping or informatics standards. The most widely adopted framework for sharing documents within institutions, regions, states, or countries is the IHE Cross-Enterprise Document Sharing. XDS allows for a federated system of repositories within a registry to provide coordinated access to the documents. FHIR provides equivalent functionality to XDS that can be used to implement XDS behind the existing XDS interface, to provide a simpler, mobile-friendly interface to an existing XDS ecosystem, or to link document sharing into the other functionality provided through a FHIR interface. The third section is decision support. One common use of healthcare information systems is to integrate some form of decision support software into clinical systems. Common uses of clinical decision system support are drug-to-drug interaction checking, and more generally, prescription safety checks, suggesting commonly missed diagnostic data interpretation, patient surveillance for early warning of deteriorating patient health, and identifying candidates for alternative treatment plans for improved efficacy. Note that in addition to clinical decision support, there are also infrastructural uses such as managing access control. The various forms of decision support each involve different interaction patterns, so there is no single decision support implementation in the FHIR specification. Generally, the patterns fall into several classes. Any decision support may fall into multiple categories at once, depending on the perspective of a given system. Lastly, the explicit requests for decision. So essentially, when a query is initiated in order to get a decision made, the following considerations apply. The request for a decision is made using one of the interaction patterns described for search or query. This is often a RESTful search, a query posted to mailbox, a query message, or the asynchronous query pattern. The request has an underscore query parameter that identifies the decision that is being requested. The request also has a set of parameter values. In some of the query interaction patterns, the resources identified in the parameter value can be bundled up with the request. In others, only the reference can be passed. So these are just a few of the specific use cases of FHIR. There are quite a few. Feel free to take a look around. Let's discuss some of the challenges and weaknesses of FHIR. So FHIR is a very generic informational model and is not always the easiest and fastest way to implement specific use cases. You will probably need to extend and adopt FHIR models to your specific needs. The migration between FHIR versions is painful because of no backward compatibility. However, there are promises of backward compatibility starting from the non-native version, which are very soon going to be released. The FHIR extensions and profiles can be complicated to use. FHIR resources need to be extended when dealing with specialty health data that falls outside of the most commonly used clinical data. We've applied a lot of effort to simplify FHIR extensions in a few places, but some of the other reasons why FHIR also struggles is because it just cannot do everything. For example, FHIR does not address technological concerns such as system architecture, system to system integration, security, and analytics. The standard was built to enable interoperability and not meant to address these technical considerations. These are the problems that a lot of people face daily, but a lot of us are also trying to work on these challenges by providing a complete toolkit um, for others to work on. The FHIR standard API is limited and probably won't be enough for your real app. Life is always more complicated than we want. With a lot of these cases, some you may find a lot of online help that would provide a generic way to extend the FHIR API with additional endpoints, more powerful search, business intelligence tools, and more. FHIR also is not a security protocol, nor does it define any security related functionality. The standard wasn't meant to address security, so you must build HIPAA technical safeguards. FHIR doesn't address infrastructure either. The modern healthcare solutions need to be both secure and reliable. So now let's discuss how to stand up a FHIR server. So let me quickly get back. I am just trying to see how to exit the app without. Here, found it. Sorry about that. So, in order to get the FHIR server up and running, I had cloned the repository HappyFHIR JPA server starter. Then I launched the server by essentially running this command. So I already have Maven installed locally, and so I'm trying to get the Chetty server up and running. So I run this command so that I can run the FHIR server locally on 8080 post. Once that is done, let us log into localhost 8080, and the server is still running. Just takes a few seconds for the first time. And it's up. So you can see we have our FHIR server up and running. So now let's take a quick look on how to do some of the CRUD operations. So here I have a few files where I have taken a note of all of the basic CRUD operations, and then I have also written a few tests using which we will essentially test all of these CRUD operations. So mainly in a gist, we will be working with patients' resources by performing CRUD operations on it. So let's start with read. So here is the simple read operation. We will search whether the part of the patient's name matches the value, and the search will return us a bundle of results. So a bundle essentially is just sort of a collection, or a bundle will contain multiple patient resources that we will read one by one. Just in case if a bundle has linked to another bundle, then we would continue and we would link that as well. So how we do that is we come to the FHIR server, we click on something called patients, and then we search. once we do a search, we see that we currently have 2 patients. Let's read both of these patients just to get to know what we're looking for. So here this patient's name is John Doe and the patient ID is 4952. Let's go back and read the other patient. This patient's ID is 4953 and the patient's name is John XYZ. So let's come back to our file here. Here we're going to run the function getID by patient name. It takes the name as a parameter. And so the aim of this function is to essentially get a substring name and go and look for all of the patients where the name matches or a part of the name matches with this particular name substring. So that's exactly what we're doing here. We have a client and we're going to run a search on it. And we're going to look for a resource where the patient name matches with the value provided. And we're going to return a bundle and then we're going to execute. So let's quickly look at the test file. And so here, here I have changed the server base to be to point to the local host instead of the production FHIR server. And here the string name is John, just because we want to see if it would return us both the patients or not, since we saw that we have 2 patients by the name of John. So here are the IDs of this patient. And now let's run this test. In order to run this test, I'm going to just run this command, which is essentially asking Maven to run a single test by the name of simple read test. And let's run it. And the test passed. So which means it matched John and it mapped it to both 2 patients with ID 4952 and 4953. So read activity is done. Let's quickly take a look at how to create a new patient. So let's go back to patients. How we would create a new patient resource is by a given first name and last name, and then it would return us the ID of the patient created. We're going to verify that this patient has been created both from the terminal and on the FHIR server. So we are going to look at advanced add test. In here, this is, we're going to look at this file. The other file was the test file, which we're going to look at shortly. So here, this new patient takes a first name and last name as parameter, and we ask to create a client with the resource new patient, which we just added, and we're going to execute it. So advanced add test file here, let me create a new patient called Mona Rajans, and there we're gonna print the ID and patient details, and then we're gonna map then we're gonna check that this particular ID also exists on the FHIR server. So the same way how we ran simple read test, I am going to update this to advanced add test. Okay, so our test was successful. Now let's confirm from here that our patient was created. Let's create a new search and we have a new patient. Let's read this patient and see whether it has the name Mona Rajans as we created. Looks like it still is getting Mona ABC. Oh, that may be because I did not save my file. Let's try again. And here, as you can see, now it gives me the patient Mona Rajans, and this is added here as the fourth patient. So this is how we create a new patient. Let's try and update a patient. So as we saw, this patient had no phone number. As you can see here in the response, there is no phone number attached to this patient. So let's try and do that. We can go to the advanced update file. In here, we're pretty much doing the same thing, but we're taking a patient ID and getting the phone and adding a home phone number to this patient. So let us get the ID of this patient. It is 14953. Let's go to our update test. So 14953. So 14953. And let's add just some random phone number to it. And now let's advanced update test. Okay, so that was successful. Let us quickly check this patient again. So the patient we updated was 14953. Let's run a read on it. And voila, this patient now has a home phone with the same phone number that we added to it. Similarly, we can delete any patient. So let's go to the advanced delete. Here we have the delete patient function, and essentially we're deleting this patient and we're passing the patient ID parameter. And now in advanced, let me copy the patient ID from advanced update to advanced delete. And this should delete this current patient that we're looking at. So if we go back now after our tests have passed, we should only see 3 patients. So now let's do a search. Did I save the file? Oh, that is because I did not update my command. I was still running advanced update. So let me run advanced delete. And now it should delete the last patient. There it is. Patient ID 14953 has been deleted. So those are all of the CRUD operations that we're supposed to do, that we can do on FHIR. Let's go back to our development. So I just showed you how to stand up a FHIR server. We also did, a basic exercise on the CRUD operations. I showed you how to use bundle in the code. And I also demonstrated how to search for FHIR data using the patient resources. So quickly talking about the FHIR data types. So typically the FHIR data types are, the FHIR specification defines a set of data types that are used for the resource elements. There are 4 categories of data types. The first is simple primitive, which are essentially single elements with a primitive value, which you could see here. So all of these are single elements with a primitive value, like this element could be date, time, and so on. There are general purpose complex types, which are reusable cluster of elements, which is why you would see that these do not have a primitive value. This can be a range or an annotation and so on. There could be metadata types, which is a set of types for use with metadata resources. And then there are special purpose data types. So these are typically defined elsewhere in the specification for specific usages. A limited set of these data types may appear in extensions. All data types, including primitives, may have extensions, but only the following data types may include modifier extensions. These are timing, dosage, and element definition. Talking about FHIR extensions, this Exchange specification is basically on generally agreed common requirements across healthcare, covering many jurisdictions, domains, and different functional approaches. It is common for specific implementation to have valid requirements that are not part of these agreed common requirements. So, as such, extensibility is a fundamental part of the design of this specification. Every element is a resource and it can have extension that child elements to represent additional information that is not part of the basic definition of the resource. So, unlike in many other specifications, there shouldn't be any stigma associated with the use of any extension by any application or such. The use of extensions is actually what allows the FHIR specification to retain a core simplicity for everyone. To make the use of extensions safe and manageable, there is a strict governance applied to the definition and use of extensions. Although any implementer can define and use extensions, there is a set of requirements that must be met as part of the use and definition. So in this particular case, this is the basic structure of how an extension is. There is a URL which typically identifies the meaning of the extension, and then there's a value which stores the value of extension. Talking about any other useful stuff, I try and cover as much ground as I can, but FHIR, as you must have seen from this video, is a huge and extensive subject, and it is very, very much coming more and more up to speed. So the best way to get up to speed is with getting lots and lots of practice. So I would encourage that you go back and read more of the documentation, or if you want to probably go back and see and take a look at the code and see how I implemented all of the CRUD operations, that would give you a good starter hint as well. So that is all. I hope you enjoyed the video. Thank you.